Uh, yeah, there is some. There is not a lot of information. Available to freshers about how to get into this domain, and it is there is some barrier of entry into this domain. So we thought we will do a session on this and see how people can leverage this opportunity. Okay, so moving on. Okay, so this will be my agenda for today. I'll give some introduction to what is really VLSI engineering and why choose it, and how the career path progression is, the salaries and perks, how to get into the industry, and what ASDC, which is Advanced Skills Development Center, which is the which is managed by Career Guidance Council people. So how we can assist you guys to get into this VLSI domain and what you need to prepare, and then we'll open for question and answers. So I put question and answers at the end, but you can always stop me. You can, if you have any question, you can please interrupt me and you can ask the question. No problem. Okay. So moving on. Yeah. So we have all these things, right? These are things which is all around us these days. We have cars, fighter jets. Yeah, but I mean, these are all cutting edge technology, right? Satellites, Internet of Things, where you have all connected, all the devices in your home connected and talking to each other. You have big data centers here, and then you have computer accessories, any cybersecurity related stuff where you're logging into your logging into your email, or even this Zoom meeting with the passcode and all. And then you have your appliances, home appliances, medical devices, all these. This is an MRI machine, and of course your PCs and printers and robotics. The question is, what do all these have in common? What is it that is making all these run, right? So no prizes for guessing. So the thing that drives all of these, that is the heart of all of these, is the integrated circuit, which is also called IC. It is also called, in common language, it is also called a chip. Yes, there's a question. Is there a question? Is there a question? Somebody raised a hand. No? Okay. Yeah. So this is the integrated circuit, or IC or chip, whatever you call it as, right? This is the brain behind all of these. And even if there you have a simple like a microwave with a display panel, right, or a control panel where you have to press some buttons, anything like that will have an IC controlling it. So an IC or the integrated circuit is all around us. We are surrounded by it, and we don't realize how much it has penetrated into our lives. Okay, so yeah, moving on. So how do I get this now? Okay, yeah. So introduction to VLSI engineering, right? So what does VLSI stand for? It stands for very large scale integration, also known as chip design, also known as semiconductor engineering. There are multiple names, but most of the time it means the same thing. Process. So what really, if you go with by the technical definition, right? It is the process of creating an integrated circuit, or IC, combining billions of transistors into a single chip. What is a and IC design started off with two transistors. When the first designs came out in the 1960s, it had only two transistors. But now, if you see a modern design like a Intel Core i9 11th gen CPU with 8 cores, it consists of 6 billion transistors. I mean, these are huge numbers, and these are so tiny you can't even see with your naked eye. You need an electron microscope to be able to get some visibility into the transistor level. So And there's this common misconception that when we say IC design or VLSI design, some people confuse it with printed circuit board design. So this is a printed circuit board, right, which has all these connections, and you have the chips connected to each other, talking to each other. So when we refer to VLSI design or IC design or semiconductor engineering, it refers to the design of these ICs. What is inside these ICs? What is inside these black chips that you're seeing here? It is not the design of this board. The board design is usually called PCB design, or loosely called hardware design. But VLSI specifically, or IC design specifically, refers to what is inside these ICs. Okay. Yeah. Moving on. Uh, yeah. So why choose VLSI, right? The question is, why do you get into this? There's software, there is cloud, there are so many other domains, right? Why would somebody want to choose VLSI, and why it's a great time to get into VLSI is because of what I put in these slides. I've tried to capture some screenshots from the internet. So if you see, right, the semiconductor design market in India has blown up every year at a rate of 30% almost from 2015 to 2020. And there's only going to, this is a past number, but it is, I can tell you that this has only become more faster. This is the rate of increase has only increase. The rate of increase has only become more steep, and now the growth is even higher than what this chart shows, right? And if you see, right, according to the Semiconductor Industry Association, semiconductor sales jumped 27% globally to $50.7 billion in Jan 2022. So as you can see, right, in the first slide that I showed you, and all these things which had ICs, and they are penetrating all parts of our lives. So it's no surprise that the semiconductor sales are going through the roof. Okay. And specifically in India, right, you see how much growth is expected. You see, yeah, I mean, like if you see this screenshot, right, so that growth rate of 30% electronics production in the industry in India is hopes to be at $410 billion by 2025. Some people say $500 billion, which will be 8.2% of the GDP of this country, as against 3.2% now. That's a huge number, right? And even the government is also trying to give a lot of incentives and encourage a lot of encouraging electronic companies, semiconductor companies, to set up design facilities as well as manufacturing facilities in India. This is the technology, this is the technology cold war that has started now between nations, and everybody from India to European Union to US to China, everybody wants to get into semiconductor design, because this is the cutting edge of technology. Any software you want to runs on these ICs. So whoever has the best technology for the ICs, or whoever is has the technology to make the ICs as intend as required, will be at the cutting edge of the latest technological trends. So it is very important, and there's a huge talent gap also. I mean, there's a lot of requirement for job requirements, but people, they're not able to find the right people to fit in. So you can see, this is one of the directors of IIT Delhi who owns some startup. This is what he's saying: I cannot afford my own PhD students, because the student's salary as soon as they graduate is almost half of his. In 5 years, they would be earning much more than what I would be making. And because so uh, they have a huge requirement of VLSI implementation, and they have nowhere to go. All these companies, they have a huge requirement, but there are not enough people to fill these jobs. And as you can understand, when the demand for resources, when the demand for when the demand for workforce increases, and there are not enough people available, then naturally your salaries and your perks, all these things will go up. So which is what is in my next slide. So right, uh, silicon is fast replacing steel. There is disruption happening in every industry because of this. Who would have thought just 10 years ago, Apple alone will sell 30% more watches today than all the Switch watch companies combined? So this is talking about the Apple Watch here, right? So previously, when you were wearing a watch, the best you could wear was some Swiss companies watch, right? They were all very sophisticated designs, and but now the latest trend is the Apple Watch. It won't just show you the time, it will do so much more. It will give you your health parameters. It will you can receive calls on it, you can watch your notifications, you can do so many other things with this Apple Watch or any other Android watch also, right? So and Tesla, right? Tesla has a huge is a huge investor in technology for self-driving, right? Self-driving cars. So they use a lot of artificial intelligence and machine learning based processing for which they need these integrated circuits which are present in the car to do all the processing. They need very custom made ICs to take care of all the processing requirements, right? So VLSI is at the heart of this revolution. India has a huge opportunity to become a major player in this space if we play our cards well. And they are even proposing to have a specialized VLSI engineering program, not just, I mean, even though it is VLSI is covered a little bit in electronics and poly engineering and instrumentation engineering and all, but they want to have a separate program just for electronics and VLSI because there's so much requirement for people with this talent. Okay, so uh, so like I said, the ICs are everywhere. You cannot do without them. You cannot live a single day without them. And the late and so far it has been cell phones, PCs, data centers, game consoles, web servers, graphic cards, appliances. But the next wave, there is a even bigger wave. I mean, there's a fresh wave of IC requirement that has come up. That there it is driven by AI and ML chips, AI and ML. AI and ML use cases, Internet of Things, 5G, smart automotives. They are even they are driving the demand for semiconductors even more, right? And even software giants like Google, Microsoft, Meta. Previously, they were purely software companies, right? Now they have started their own chip design teams, where VLSI design teams, where they're designing their own chips for data center and artificial intelligence AI applications. Okay, governments across the world, like I said, US, India, European Union, they're encouraging semiconductor design. They are giving tax benefits. They are they're allocating special economic zones for uh, people to come and set up their design facilities, manufacturing facilities in their respective countries. And also one of the good things about VLSI is, like, if you take software, right? Software, every 4 or 5 years, some new API will come, uh, some new language will come. And like every 4 or 5 years, there'll be a completely new way of doing things, and things change very fast. So you have to keep relearning, and you have to be on your toes all the time. And every 4 or 5 years, you have to reinvent yourself in software. But if you see VLSI, because it is so complex and it's a whole ecosystem required, there's a comfortable pace of learning. Things are, I mean, there is of course a lot of evolution happening, but it is at a comfortable pace. It is at a pace where you can keep up without getting too stressed. So that is one good thing about VLSI compared to software. Okay. Um, any questions? Okay. Moving on. Okay. So domains, right? Sorry. Mhm. Yeah. So what are the engineering domains in VLSI, right? Can moderator, can you unmute? Some people have raised their hands. Can you type the questions in the chat, please? The host, whoever is the host, can you unmute these people who have raised their hands, please?
Good
Amin?
afternoon, sir. Good afternoon, sir.
Yeah, tell me.
Yes, sir. Myself Aminuddin, and I am pursuing MTech VLSI.
Okay.
So I am doing practice on cadence tool, sir.
Okay.
So I am unable to do as much as practice as I want to do, but because it is due to limited time will be in college, I want to get access in my laptop. Can I get?
That is the thing, right? That is very
Because
difficult
we
because
have to practice a lot.
these tools are very expensive, and they cost huge amount to get a single license. It's not
So
easy. That is the
just
one.
for just
Yeah,
for studying purpose, what should we do, sir? Because I
I'll
am in
come to.
first year.
I'll come there. I'll come there. Let us park this question for now. I'll come to you. Okay.
Okay, okay, sir.
So because this is a more broader topic that we can discuss in how to get into the industry, right?
Yes,
Try to.
yes.
Okay. I'll
Okay,
come
sir.
to that in the upcoming slides. Okay.
Okay, sir.
Thank you.
Hello.
Yeah.
Sir, what are the career opportunity in system Verilog?
System Verilog. Okay. You see this, right? It is mostly in verification and a little bit in the design. So let me show you here. Okay.
Okay.
Yes, sir.
Yeah.
So, what is the opportunities of computer science graduate?
Computer science graduate. This is VLSI is more for electronics people, right? Electronics, electrical instrumentation. So computer science will be more suited for what you call embedded system programming, right? Embedded systems.
Okay.
Excuse me, sir.
Yeah.
Sir, like what is the difference between analog VLSI and digital VLSI? Which one is better, sir, and which one has a good growth, sir, in future?
See, both are important. Both are important. It's not like one is better than the other. You can, they cannot do without each other, right? Analog cannot do without digital. Digital cannot do without analog, right?
Sir,
So there is opportunities in both, and it depends on your taste and what you prefer to do. Right? Digital is more about like kind of writing the code and trying to. Um, Vertical. Okay. Let me go through this slide. You guys will understand it.
excuse me, sir.
Yes.
Sir, I
Yeah.
had one question. You are saying that VLSI engineering has these many domains. So,
Hmm.
from which domain is the best, sir? From as a fresher, what to on which areas I have to focus to get best future, sir?
I'll come to that in the upcoming slide. So thing is,
Okay, sir.
there are different things, right? There is RTL design coding, there's verification, there's physical design, there's design for test, there is layout design, right? So I mean, it's not like which is best or which is it depends on what suits you best, right? What you prefer to do. A lot of times what happens is that once you went into some training institute or into the company, right, you will be exposed to, you will be given training, right? In that training you can try and figure out what suits you. RTL design and coding. Okay, let me get through these details first, then I'll come to your question. Okay, so what are the domains, right? First is like concept is more like a product manager kind of guy, right? So they will be like coming up with what do I really need, what does the market need. Okay, Google is having a big data center, they need a lot of processing power, they need a lot of communication. So I need a data. So for example, the product manager will say I need a data center chip with 64 processor cores and 32 megahertz DDR4. It should be able to communicate with the RAMs at this speed, and should be able to have a USB interface as well as a PCI Gen 5 interface. So we need this to take into the market, and we can sell a lot of these. This is what the concept is, right? So this is the product manager will come up with this. So they will give these inputs to the architects, and then the architecture guys will basically say, okay, so this is what the market needs, and so we need these kind of features and blocks and power, performance and goals, performance goals and area to be able to get a product, get a good product fit in the market, right? So if you see, like, if you're designing, say, if you say talk about, say, power, right? If you're designing for a laptop, you have to have a good power management. Your the laptop battery should not drain fast. At the same time, if you're designing for a desktop processor, which is always connected to power supply, and which is mainly meant for gaming or very high end processing, there you don't worry so much about power, right? So there you can say, okay, power is okay. You can specify a much looser requirement for power, and there the more important goal will be performance, right? And then area again. So if you are designing for a laptop or a mobile chip, area is very important. You cannot have a very big die which but takes up most of the area, and you can't fit in other things. But if you have a desktop, or you have a server board, right? And server board, enterprise servers in the data centers, you have board for that. There they may have more area, so there the area is not so much of a concern. So the architects will look into all of these things, and they will try to give the specifications to the other teams, the teams which are actually designing the blocks, right? So they will give the specifications that you should design for these specifications, right? So typically the concept guys and architecture guys are more senior folks. You need a lot of experience to understand what will work, what won't work, and it needs a lot of breadth. You need very wide knowledge for these roles. Okay. So once the architecture guy gives you the specification, then the individual block owners, like you have a PCI block owner, you have a USB guy, you have a DDR guy, you have a processor core guy, you will have some, there'll be and all these will be communicating on the chip using some specific protocol, some specific design which will help all of these communicate with each other, right? So there will be a separate block for that. So all these blocks, so the once the architecture gives specification to all of these guys, they will go and design, right? So some of the blocks may be digital, some of them may be analog, right? Analog is more the ones which are actually managing the power, managing, communicating with the outside world, because analog is more continuous signal, right? And digital is just 1 or 0, right? So digital is like you have a transistor which is either on or off, right? So digital is binary, but analog is a continuous signal, and the real world the signals are continuous, right? So anything which communicates with the outside world, manages power, and all those things will be in analog, and the other blocks will be the logic blocks. Logic stuff will be in digital, right? So some of the blocks may contain both analog and digital, right? So if you go towards the digital design side, can everyone go on mute, please? Okay. Yeah. So if you're on the digital design side, right? So the first thing is whatever you're designing, you will define the behavior of that, right? Like if you have a processor core, right? Then you will specify, okay, this is my floating point unit. This will do these operation, will do addition, subtraction, multiplication. And I'm telling you in a very simple way, but there is a lot of complexity involved there. And there's a integer unit it will do, and then there's a instruction fetch unit which will fetch the instructions from the RAM, and it will basically ask the RAM to send the and give the address to the RAM, and ask it to fetch the instructions which are required to be executed, right? So all these things, all this behavior has to be designed and defined using RTL. RTL is registered transfer level. So basically, it is a language specifically designed for VLSI coding, VLSI behavior coding, and uh, so once you have the design and coding, right, then there are two parts. One is verification. Verification is basically whatever this architect specifies, right, that your block should do this. So the verification guy will actually check if whatever these RTL guys have written is actually behaving this way or not, or they're saying something but the actual code is behaving in a different way. They'll run a lot of simulations, right? They will run a lot of simulations to see if your design is meeting the required uh, specifications or not, goals or not. Okay. So once, so this is going on in parallel. This is going on. The verification is going on once the design and coding is done, and at the same time they will start with the physical design. Physical design is mostly converting this code into the transistor level on the which will actually get manufactured on the silicon. This is just a behavioral code, right? So if you have in the code, you can just you can what is that? Yeah, you can write something like C equal to, if you can in Verilog you can write C equal to A and B. So if they both A and B are one, right, then not like this, A and B, right, like this we write. So if both A and B are one, then C is one. Otherwise, C is zero, right? You will write just this. But what the physical design guy will go there is that will do is that they'll make sure that this is actually implemented using transistors. So you will have a input coming which is connecting to some gates, and I mean and then you will get the required output, right? So the actual transistor level connections and making sure that those transistors work well and they are manufacturable. Basically, there are a lot of rules that each of these all the manufacturing units, right, we call them foundries. Foundries will give you a lot of rules that need to be followed to manufacture these transistors and the IC. So the physical design guy will make sure that they are following all these rules, and once it goes to the foundry, there will be no problem. So there is a lot of hundreds of checks involved in making sure that uh, and the actual transistor implementation is working as per the design. It will go through the manufacturing process smoothly, and even after manufacturing, it will have a decent life cycle. It will not fail, right? And also you will have to and also they ensure that the frequency goals are hit, right? So if you go to if you go to buy any CPU, you will see they'll specify this runs at 3.5 gigahertz or 4 gigahertz or 2.5 gigahertz, right? So so the physical design guys will actually make sure that it is you're able to run your design at those frequencies. So all these consist of the physical design, and in India, a lot of work is related to physical design and verification. There, of course, there is work related to RTL design and coding also, but a majority of the teams are working on verification and physical design. Of course, that does not mean you cannot go into RTL design and coding. There are companies and teams doing that also. But these are more penetration, verification, and physical design as of now. But it is changing. RTL design and coding work is also coming to India. A lot of it is going on currently now. So that is on the digital side. And then if you go to the analog is like basically it is more like communicating with the outside world, right? So they will tell you, okay, I need to if it is a USB signal, right, the ones which is where you're using to charge your phone, or you're using a USB cable to charge your phone, or you're using it to connect it to your PC. So the USB specifications will say that, okay, your signal that is going out of your or out of your chip needs to be of this voltage and this much current it needs to drive. It needs to be able to drive this much amount of resistance and this much amount of capacitance, and this is the frequency it needs to run at, and it has to filter out this much amount of noise and all those things, right? So low pass filters, high pass filters, all those things, they are heavily used, and um, that is what the analog guys will do. So they will implement these circuits using a schematic design, and they will do a lot of simulation to make sure that the design schematic design is behaving the way they want. And once the schematic design is complete, they will send it to layout design. So layout design is more like physical design, where the schematic, the transistor connections are actually implemented in a manufacturable format, right? So once you are done with your physical design and layout design, you get one big file which will have all the description of the transistor locations, how they are interconnected, how the metal connections are, how one transistor is connected to the other using which metal. There are multiple metal layers, like metal is basically wire connections, right? So there are multiple layers of wire connections. So you can have 11, 12, 13 levels of wire connections that are helping to connect these transistors to one another. So you'll have one big huge file which will have all this description of where the transistors are and how the wire connections are, and that file will go to the foundry for manufacturing. And once it comes back, then you have your validation is basically making sure that the silicon, the IC, manufactured IC, is behaving as what you have designed for, right? Whatever you have designed for and specified, it has to behave that way. So that is validation. There's also one domain called design for test. This is a relatively smaller domain, but it is very important, equally important. So this is basically, this will help you test. It will basically add logic to the chip, there which you can use, to test the chip once it is out of manufacturing. Once it comes back from manufacturing, do validation. You need the logic which is put in by the design for test team to be able to test the chip properly. Okay. So yeah, so if you are asking me which one of this is important, all are equally important. There, like I mean, if you see the cost of manufacturing one chip, right? So if you manufacture one chip or hundreds of chips, all of that is done using a mask. A mask is basically where it will tell you where the how the transistors are laid out on the silicon and how the wire connections are, right? So each manufacturing one mask will cost you millions of dollars, in millions of dollars. So in rupees, it will be hundreds of crores. So any of these guys makes a mistake, it can be very costly, right? So that is why there's a lot of hundreds of checks done before the actual chip is sent out to the fab for manufacturing, or to the foundry for manufacturing. Okay, so there's no such thing as one thing which is important and one thing which is not important. Roughly, I can tell you one thing is, like, if you are into verification, right? Verification is more like about being diligent. You're being diligent, and you have to. This is actually testing the scenarios, right? Where you are saying your chip is your block is designed for to purpose to fulfill some so and so purpose. So you have to think about all the corner cases and how basically what all if you have tested all the required scenarios or not. What if this input comes before this? What if this input comes after this? What if there is an error? Will it work? Will the design be able to recover, or it will get stuck? Or will the chip hang? So all these things, right? So they come under verification. So if you want to go into verification, typically the kind of skills that you would need is, you have to be very diligent, you have to be very thorough with things. If you like taking up a thing and following it all the way to the end, and thinking about all the possibilities, all the possible things that can go wrong in doing something, yeah, that is a skill which will suit verification. Okay. Physical design is more like mm, if you talk about physical design, it's more about experimenting with things. So you have a lot of tools which will help you convert this design into a silicon manufacturable format. So you'll run all these tools. You will try to understand what is the I mean you will try to basically do multiple experimental runs with these tools to see that you'll have different recipes basically to see that your design is actually working at the required frequency. It is meeting the power goal. There's not a lot of leakage. There is when you're running, the current draw should be within limits. So physical design, what happens is there's no you don't know the solution in the beginning. You basically uh, do trial and error and try to figure out what will work. So physical design is like that, and it's also about a lot of things. A lot of times you'll have to do a little, quite a bit of scripting to automate tasks. You have to write small programs to basically process all the information that you're getting from the tool and to be able to draw meaningful conclusions from them. So so these kind of skills, like good if you are good at scripting, writing small programs, it's not very algorithm intensive. It's not like you'll have to like design some very smart algorithm like you do in computer science or software engineering. It's not like that. I mean, simple logic is enough. If you have good decent logical understanding to write simple programs and analyze all this data, and try to fiddle with the tool and see, okay, what will this setting do? Will I do if I put this setting when I'm doing when I'm running it through the flow, will I get a better power number? So these kind of skills are important for VLSI, for physical design, right? And that is on the digital side. Analog, again, schematic design is again about trial and error and fiddling around. And but analog, one thing is you really need to be thorough with the electrical concepts of the transistors. You really need to be on top of that and understand how the basic working of the transistor. It's, of course, it's important in the digital side also, but analog you will use it every day. And the basically the basics of electrical sciences, right? And the transistor level details and the working of the transistor, that is most important for analog design, analog schematic design specifically. Okay. And then layout design is more like there are set of rules that you need to follow and get the schematic converted into a transistor level format. So, and design for test and validation, if you see, it is more about uh, thinking about what can go wrong and how can what do I need to put into this chip to be able to test it. Once it comes back from the silicon, there's nothing you can change about it, right? Because it's very high technology. There are very few companies in the world who can actually manufacture an IC today, right? So, and all of this is done using very sophisticated machines. You cannot change anything on the silicon, on the IC, once it comes back from manufacturing. So you have to think of all the possible cases where it can fail, and how will you catch each type of failure. It's basically about uh, doing your diligence, doing your hard work to figure out in what ways a silicon fail, in what ways the IC can fail, and in what ways you can catch those failures. It's not about only if it fail, okay, you throw it away. No, but you have to specifically be able to tell why it failed, which part of it is failing, and what, in if there are ways to work around that, like can you disable this block and still make the chip work for some other use cases. Say USB is not working, so I'll take out a product which will where where I'll sell it saying that, okay, USB is not working in this, but you have the other features. If this works, and if there's a customer for whom that USB is not important, they will go and buy it, right? So there's so design for test and validation guys, they have to really think about the possible ways they can catch a failure on the chip. Okay, I hope that answers your question on which is better or which is not. Okay. Okay, what are VLSI opportunity in Hyderabad career trends? So this I will come to the upcoming slides. We can if you after I cover the after my presentation is done, if you still have these questions, you can ask. Okay, I think we need to, yeah, we need to. So typical career progressions, right? So it's 0 to 5 years. So once you get into the industry, for first 5 years, you'll be mostly an individual contributor. You'll be told what needs to be done, and you'll be expected to try and go and figure out how it's done, right? 5 to 8 years, it's more like you start owning tasks and simple tasks and some crucial tasks also, and maybe manage one or two people, and manage be responsible for the delivery of some of these tasks. Okay, 8 to 14 years, it's more of a leadership position. Now these people are expected to lead more important verticals, like they can be responsible for the ensuring that the chip is working at the right frequency, the whole IC, right, all these blocks, they're working at the required frequencies. Or it could be about power, right, the how I can reduce the power numbers across the die, across the chip, how I can who needs to do what to reduce the power numbers, all these checks, right? I mean, so these are important checks, right? So across the block or across the chip, these 8 to 14 years senior member SMTS guys, right? These guys will own those parts. Okay. And then if you're going on the managerial side, so this is on the technical side of the ladder. If you're going on the managerial side, then that manager will basically be responsible for 4 or 5 people, and the small team he will be leading. You go from 14 to 50, 14 to 18 years, then you'll be going to the PMTS level, the principal member level or the senior manager level, where you'll be expected to lead across multiple verticals, guide a lot more people, manage a bigger team. And then the next level is the fellow or director level, where these guys are expected to lead the development of the entire chip, basically all the different verticals like power, performance, area, verification. All these, one guy has to be able to influence all these things and drive them and provide guidance for them. Okay, so this is a typical career progression. Salaries and perks, right? So salaries is most like full-time employee at tier or product companies these days, because of the huge demand, starting at about 14-15 lakhs per year. And as you go gain more experience, right? If you have you can multiply 4 with the number of years of experience you have. So if you have 5 years of experience, like 10 years of experience, 4 into 10 is 40. So you can expect a package of 40 lakhs per year. Plus, again, there are good bonuses, 11 to 20% of your base salary, and 10 to 15,000 USD of stocks. Like 10,000 USD is like or almost 7.5 lakhs, right? So this is a yearly stock allocation that is given. Right. So this is for usually at the top product companies. If you are at a smaller product company or startups, you may the pay scale may go down a little bit, but this is like at the top end of the spectrum, right? So if you're a contract employee on payroll service of service provider companies, so like there are service provider companies, right, who will basically take you, who will basically hire you and send you to other product companies to do the job for them. On a contract basis. You'll be there for 1 year or 2 year as a contractor. You'll be working. So for these guys, the starting salary is more like 3 to 5 lakhs per year, and experienced guys, the salary will be more like 2 to 3 times the number of years of experience, right? So if you have 3 years of experience, you can expect 9 lakhs or so. Okay, so typically, because on the contract, right, because some company is sending you to do the job to some other company, so the whichever company is sending you as a contractor, they will also make money out of you, right? So because they are training you, they're hiring you and training you and providing you a platform to get a job, right? So they will also make money out of you. So typically the salaries for contract employees will be less than full-time employees at the product company. So you should, like, typically when you start as a contract employee, right, at a company, should try to they may have some bonds which they will need you to sign. So once the bond period is over, you should try to get, you should, I mean, even though the salary is less, you should not get discouraged. You should try to work hard and learn, and then once your bond period is over, or if you get a good offer, right, you can jump to a full-time product company, and your salary will become on par with the rest of the industry. Okay, so but you should be patient to learn, and should not compare with other guys. Oh, this guy is at the product company, this guy is a full-time employee, is getting so much, I'm only getting this much. But uh, at least you have got into the industry, right? So in the future you can expect to, in the long run of things, you can expect to get a much decent salary, right? You'll get you'll have a good lifestyle and a very good salary, but you have to be patient the first few years and should not get discouraged. If you keep comparing and saying, oh, I'm not getting so much, but these guys, you have to remember that those guys are full-time employees, right? And they are probably from some top tier colleges who have got into these companies directly, so that's why they're getting so much. It is very important to keep the long-term goal in mind, and for 2-3 years, if your salary is not up to the level because you're working as a contractor, you should not get discouraged. Okay, and in the industry, there are other perks like PF, gratuity, medical insurance, workplace facilities. These are on par with the IT industry, any software company. All the facilities and these perks will be on par with them, and in some cases better also. Okay, so moving on, right? Now, the most important question that you guys were asking, right? How to get into the industry. So you have to remember one thing is that see all these like in software, what you can do is, if you want to learn Java, you can simply download and install Java, or you can download and install Python or C and learn. And you can, even if you want to do app development, right, you can just write an app and get it productized also, all while sitting on your laptop, everything for free, right? So it is in the software, there's a lot of drive-ins, walk-ins that are happening, because people can gain that amount of skill on their own. But unfortunately, in the VLSI industry, there are a lot of there's a lot of dependency on tools. There are tools which will help you do your designing, right? There are tools which will help you. You cannot do without tools. Then these are very sophisticated, very expensive tools. Even one license will cost you in lakhs to get these tools, right? So basically, so that's why you cannot. Somebody was asking here, you cannot upskill yourself to that level, to a to an industry relevant level, just by using your laptop. Like somebody
Excuse
is
me, sir.
asking for, yeah.
Sir, tools are required in both the fields like analog and digital.
Yes, it is required. I agree. But that's what I'm saying. These are very expensive tools. You cannot, for a student, you cannot expect to get a tool. The only way you can get a tool is if somebody else, some institute or your college, if they're having that license for the tools, you can go and use them. Okay. So you cannot, if you want, you cannot go and install your Cadence tool on your laptop. First of all, it won't run on your laptop. It needs very high configuration machines, Linux machines, to be able to run those. First of all, okay, that is why the barrier of entry into getting into VLSI industry is very high, because you cannot upskill yourself to industry relevant level all by yourself. So that's why you will see very few walk-ins happening. I've not heard of a freshers walk-in which is open for everyone. They may do some walk-ins for top tier colleges, but other than that, I've never heard of a walk-in happening for freshers. Okay. So there are mainly three ways to getting into the industry, as you can see on this slide. Full-time employee campus hiring, right? So this is mostly for national tier 1 and 2 colleges, NITs, IITs, RECs, and some of your state's top colleges like Osmania University or Andhra University or Anna University, Delhi University. These top colleges, they'll go and they will hire from the campus. Okay, they will hire either as full-time employee, or they can hire as interns also. So this is basically for the top folks in the top colleges, unfortunately. Okay, so for this also you need to clear the test and the interview. If you are hired as a full-time employee, great. Otherwise, if you're at intern, typically it's like 9-month kind of internship, and if you're looking based on your performance, you'll be getting a job offer after the internship ends. Yeah, so but if somebody is lucky enough to get an internship, you should really be serious about it, and should make sure that you're constantly asking people for guidance for work, and be a good contributor to the team so that they can give you a full-time job offer. Okay, so and then this is the third one is VLSI Design Diploma from reputed institute. This is what is open for mostly everyone, right? There's some basic CGPA cutoff. I think it is 6.5 or 65% for some of these institutes. So once if you're above that cutoff, you can prepare and try to get into these institutes, right? So there's an entrance test, and once you clear the entrance test, they'll give you 6 months of training, right? Then fee depends upon the institute and performance. So some of the institutes may not charge you anything. They will in fact even give you a stipend of 15,000-20,000 per month for 6 months, and then they will send you as and then they will prepare you. There are some institutes who can charge you some money also. So it depends on the kind of institute, but one thing you have to make sure is the institute has good relationship with the industry, and they should be able to get you contract work at the reputed or decent companies who are doing the actual work. Okay, if you go to any XYZ institute and say I'm doing a course and try to, again you will land up in the same problem, because there are hardly any walk-ins happening. So unless these institutes send you for walk-ins or send you for interviews to the actual companies who have the work, you will not be able to you will again be in the same situation where you have done a course or you have done your graduation, and there's nobody who's actually giving you the opportunity to appear for an interview. So it's important that you go to the right institutes for this. Okay, and post training.
So,
Yeah.
so can you name some reputed institutes in Hyderabad?
Okay. Names. Okay. So in Hyderabad, Veda IT is very popular. The Moschip, there's one institute called ISS earlier. It is now acquired by Moschip, so it's called MISS something. I will get more details on those, and I'll publish those later also. Somebody suggested in the chat that there are open source tools for practice. Yes, you can use them, but the only thing is that the industry will have some specific tools from Synopsys or Cadence that they're using. It may not be completely relevant to that, but yes, for some practice you can do that. I am not aware of open source tools currently. I'll try to find out and publish those also if required, or if somebody already knows some open source tool names, please feel free to speak out for the benefit of everyone. Okay, so post training you will be you will be sent for interviews to the product companies, be hired as a contractor. Okay, so once if you're done your training with dedication and sincerity, you will be able to clear these contractor interviews easily. Okay, and then after that once you're hired as a contractor, right, once you post training, there'll be a 3 years bond. For if you're working as a contractor, there'll be a 3 years bond. If you leave the company, if you leave the institute or the company before these 3 years, you'll have to pay them some amount. So that is why I was saying earlier, right? So here in the previous slide, right, like if you target into get into the product companies after your 3 years of bond period is over, or if you get a very good offer where they're giving you a decent joining bonus and all, you can actually break the bond and go and join the product company and pay off your bond using whatever money using whatever joining bonus you get, right? So it's up to you how once you get into the industry, there are multiple things you can do, right? So yeah, so So what is ASDC going to do now, right? So like I said, right, the first two options are mostly for people who are already in these colleges. So there's not much we can do there, right? So what ASDC from their
Excuse me,
side,
sir.
yeah.
Sir, you told that 3 years bond. Sir, is 3 years bond is compulsory, sir?
Yes, if they, because they are training you and then they are sending you for work, right? So they will keep the, they will get you to sign the bond.
Sir, the bond is the bond cannot reduce like 1 year, 2 years. Why should they are giving 3 years, 4 years bond, sir, in VLS?
Because VLSI, see the first of all, there's a labor shortage, right? There's skill shortage, and there's some in VLSI. Typically, there is some. It takes more time initially to learn things, right? In the industry, there's the learning curve is takes some time. So I mean, so like that. See, the different industries have different ways of doing things, right? So they probably figured out that 3 years, may whatever training and amount that they have spent on you, right? Like I said, right, all these they are having all these licenses for the tools to train you, and you will be training using those tools with them, and you will be using that the licenses that they have paid for so much. So they should be able to get that cost extract from you, right? They all the money that they have invested on you, they should be able to get that back. If, but the
Okay.
important thing to note is you will be able to get into the industry which you are otherwise not able to get into, right? So
Yes, sir.
that is the more important thing. So for the first 3 years, you bend your back, you work hard, you learn, and then yeah, once you switch to a product company, your pay scales will be on par with the rest of the industry. You'll have all the
Excuse,
perks and all.
Okay,
And
sir.
even contract workers, it's not that bad now. It's the pays are not so bad. It's quite decent. Yeah, somebody was asking something.
me, sir.
Yeah.
Sir, doing an MTech for VLSS specialization, sir, is
Hmm.
it better to go in like foreign countries like US, or it's better to get in like tier one colleges like IITs, ISCs,
Yes, if you're getting from tier one colleges, very good.
like
I
MTech
think
specialization? I'm speaking about MTech,
yes,
sir.
yes. From tier one colleges, if you're doing MTech in VLSI, yeah, it will give you a good platform because they'll see how the campus hiring is, right? Like if you are having decent company, VLSI companies coming for campus hiring, which I guess they should be coming because there is a huge demand for workforce now.
And
So you'll be able to get placed there itself. You need
yes,
not
sir.
go. Yeah.
Yes, sir. Like one more thing is that is it better to go to US for the MTech specialization VLSI? Like
That is like if you want to settle abroad, that you can go, right?
which one is better? So like if you want to like high pay as well as, and we want to settle, so it's better to go abroad on this one.
Of course, you abroad you will be paid in dollars, right? In the US, so that is of course you'll be making more money there, right? So
Oh,
pay scales are good across the world. It's not like in India, in the US. If you compare with other industries, pay scale will be less. It's not like that. Pay scales are good everywhere. So it's just if you want to settle abroad, if you want to earn in dollars, if you want to earn a lot more, and you have no constraint to remain in India, you can of course go abroad also.
sir, can you name some like colleges in US for good having good specialization in VLSI? VLSI.
I'm not sure, man. I'm sorry. I don't know about that. You can search on the internet.
Yeah, fine, sir.
I don't know. Any of the top, I think any of the top institutes will be having definitely. But again, if you go to some XYZ university, I cannot say about that. Okay. So if you go going to decent universities, uh, it should be fine. But just because you want to go to the US, you go and join any college there, that's not a good idea. Yeah.
Yes,
Sir,
Somebody.
as a EC graduate, sir, how it
Sorry.
will be to take as a EC graduate,
Mm-hmm.
how it will be take how it will be good for to take the VLSI as a master course, sir. It is better or not, sir?
So that's what. So if you are wherever you are doing your masters, right? You can do masters at Veda IT also. Veda IT also has a masters program. Okay. If you're doing a master's at a good college where or institute where they have tie up with the industry, where you have campus placement, that's fine, right? So, but again, if you go in doing some XYZ college where they don't have tie up with the industry, where you're not, then again after doing masters, you'll come back to the same question. Oh, how do I get into? How do people give me a chance for an interview? Then again, you'll have to come into one of these institutes and do a diploma, right? Because see, understand there are hardly any walk-ins for freshers, VLSI. Okay, so that route is gone. So either you get your through your campus, through your college or institute, tie up with the industry, or you go for the using your while doing your masters, or you go with this diploma with a VLSI design diploma from these institutes. Basically, the industry connection is most important. Like wherever you're going to do your masters. Okay, and if I would suggest, right, like if you have done BTech and if you I mean if you don't have a like if you don't want to go for higher studies, PhD or something later on, and if you want to get settled quickly, then VLSI design diploma from one of these institutes is a better idea, because after getting through MTech also you're getting into the same job. You can 2 years before only, after doing BTech, once you do these 6 months training in these institute, then itself you can get into this
Excuse me,
get into
sir.
the industry. Yeah,
Sir,
yeah.
how to get VLSI design diploma, sir?
I'll come to that. So this is
Okay.
there are some reputed institutes like I mentioned, Veda IIT, Moschip, ISS. So there are I'm still collecting all those details. Okay,
Okay, sir.
I'll send out to you guys, like where I'm working with my with the director at my company to be able to talk to these guys and get the information. Okay,
Okay.
so
And in chat box
there are,
also, I asked you two questions, sir. Can you
huh?
please answer them? In chat box, sir, I have asked you two questions,
Okay,
sir.
okay, okay, okay.
You in your after the class, you can give me the answers, sir.
Real-time projects, they are very expensive also, you're saying. Is you?
No, sir. I
Can
am
have you ask the
checking.
question?
Sir, definitely, sir. How many companies providing VLSI opportunities in Hyderabad, and what are those, sir? And which location is best for VLSI? Hyderabad, Chennai, or Bangalore?
I think currently Hyderabad and Bangalore both are good. Chennai, there is the number of companies are a little limited. There are companies in Pune also, as well as Noida also. But more, if you see the majority of the companies are in Bangalore and Hyderabad, and a lot of companies like Qualcomm, Intel, AMD, Broadcom, they have offices both in Hyderabad and Bangalore. Okay, and there are quite a lot of companies in Hyderabad these days. Nvidia is there, Nvidia, Qualcomm, Intel, AMD, Marvel Semiconductor. Then you have microchip technology. So many are there. Okay, so
Okay,
Samsung
sir.
also.
Sir,
So in
yeah,
the
after this session,
hmm.
can you please send the list of all the companies in Hyderabad, sir, to everyone?
But what will you do with the list?
Because even we don't know completely which companies are providing these VLI settings, and where which company needs the which things, and what we have to learn and also, because we don't have no complete performance, like which company is best, which company is not good, where we have to try, and where where how.
You should not, as a fresher, you should not worry about which company is not good, which company is bad. First of all, getting into the industry should be your priority. If you want, oh, I want to get a job at the best company,
Yes,
best paying role, that is a very, you're narrowing down your options and making your task very difficult. You should not think like that. You should work your
okay,
way up. You should first get into the industry, for which I'm telling you this is the way. This is this institutes, right? This Veda IIT or MISS, these institutes, I will they will basically give you the they will train you and they will send you as contract employees. And then don't think just because of the bond I don't want to get. Then how will you get into the industry at all? If you want, if I say okay, so and so company is the best, and you say I want to go only into that company, how will
Yes,
you
sir.
go?
Got it, sir.
Huh? Yeah, you will not get an opportunity for interview itself. Right? If you even if you send your mail to your HR, right? They will not entertain because they don't hire like that. They have fixed processes of hiring, and they'll go with that process. Okay. So what is ASDC going to do? What to prepare for? I'll have in the next slide. I'll come to that. Okay. What to prepare, how to prepare, and all that. Okay. So my thing is
Sir,
now
your
is.
voice is not.
Can you hear me now?
Yes, sir. Now I'm hearing you, sir.
Okay. Yeah. So what to prepare, how to prepare, I'll cover in the next slide. Okay. So
Yeah,
here
okay, sir.
I'm covering what ASDC is going to do, how ASDC can help you here. So
Okay.
basically ASDC will provide guidance and mentoring to clear the entrance test for these institutes. Okay. And financial assistance to deserving candidates. Okay. For if the institute is charging you fee for the training, then the ASDC will provide you financial assistance. Okay. And most important, all the interested folks, please register at this link. Okay. Please fill out this form. I'll 1 second. I'll paste this in the chat also. Let me just paste this in the chat. So please ensure you have registered here and copy this chat. 1 second, where is the Zoom? Yeah. How come I'm okay? I can. CGC host, can you please broadcast this message, please, everyone?
Okay, fine.
Yeah. So please fill up this form. Okay, you can note it down also. Okay, you can register here, and we will send you updates on how we will proceed with this program. We are also currently in the information gathering stage as of now. So we will once if you have registered right to on this, you fill this form up. We will send an email to all these all the people who have registered on this. Okay. Okay. Please note it down. And yeah, he has the form link has been pasted in the has been broadcast in the chat. Okay.
Small query, sir. While pursuing the job, can I do this course? Is there any provision for that?
Hmm?
These courses